All right, so you guys are here for, I have to read my own slide, DDoS attack mitigation deployment models. My name is John Mize, I'm from Radware. I don't see any familiar faces. I've supported Alaska in a couple of roles in the past. Probably my longest stretch was with Cisco Systems. I was supporting data center technologies. I've been with Radware now about 6 months, kind of getting back to my security roots. In the past, I've deployed a ton of checkpoint firewalls, blah, blah, blah. Anyway, enough about me. So today we'll be talking about deployment models. This is necessarily going to be very high level. And I'm going to start out like the first half of the presentation, just kind of talking about why we even need to talk about DDoS and what exactly is DDoS. Because, and this was true of myself when I first started at Radware. Oh yeah, I know what DDoS is. It's a distributed denial of service. You get attacked and you have to protect yourself. And that was the extent of my knowledge. And there's, if you are in the security field for your IT department, the definition's a little bit deeper than that, and it'd be good to know. So I also like to have interactive conversations. So if at any time you have any questions or something's unclear or I mumble, or just stop me and feel free to ask the question. And we'll address it right away. Ground rules cool so far? All right, cool. Hot dogs. Okay, so denial of service attacks are not new. We've had them for a long time, even more than a decade ago. But a decade ago, they were pretty rudimentary, right? This is a typical internet connection for a typical company where you've got ISP goes into a firewall. You might, well, a decade ago, most people didn't have IDS or IPS. Might have a load balancer, might not. But in the end, typically you have some kind of crown jewels back in your private network that you're trying to protect. And what we would see with the denial of service attacks is it would come in and the firewall would stop it. Great. And back in the day, most firewalls, with the internet connectivity that we had, most firewalls were able to handle the attack and stop it. In some cases, it would go volumetric, which means that there would be so much traffic that it would fill up the internet pipe that was connecting your company. And so what you could do is call up your ISP, and back in the day, they were rudimentary. It was a handful of IP addresses, maybe 1, maybe 5, maybe 15 IP addresses that had been corralled into this little attack network that was doing the attack. So you could call up your ISP, give them the IP addresses, they'd block it. You're protected, great. And everybody else could get through, your email could get in, you could surf MySpace back then. So that was all well and good. But first, let's talk about the definition of DDoS. And I just ripped this straight off Wikipedia, so don't quibble with me. Go edit the definition. Denial of service attack is a cyber attack, and I'll get more into that in a little bit. But it is a cyber attack where the perpetrator seeks to make a machine or network resource unavailable to its intended users by temporarily or indefinitely disrupting services of a host connected to the internet. So generally speaking, that's what we understand. But that's denial of service. It's not necessarily distributed denial of service. So let's talk about a little bit of that. Everyone's heard of Mize, yes? Everyone, Mize? Anyone not heard of Mize? You have not heard? Okay, so you've heard of botnets. You've heard of Internet of Things, right? So Mize was the first major botnet that consisted solely of Internet of Things, compromised Internet of Things devices, okay? And so the way Mize works is bad guy stands up a couple of services, whatever, virtual, wherever, and sends out an infected bot that then starts doing scanning. And what the scanning is looking for, in this particular case, it's doing a telnet port scan, looking across the entire internet for open telnet services. And when it finds it, tries to log in. And Mize has built into its code like 63 or 65 different combinations of username and passwords of a wide variety of Internet of Things devices. Okay, so it just sits there and keeps hammering at the door until, hey, jackpot, finds one that it lets it in, reports it to this scan listen server. Scan listen server then checks its database, says, hey, do I already know about this victim? If not, we are going to load ourselves on it. And when we load ourselves on it, it is now a part of that Mize botnet. Okay, it reports into a command and control service. It is now part of that Mize botnet. Now, this is where it gets different from 10 years ago. Now, Joe bad user, says, I want to launch an attack, but I'm dumb. I don't know how to do this myself. I am going to go rent denial of service services from Mize. Pay some money to the original bad guy that set this up. Bad guy sets up, hey, here's your login for our Mize botnet. I'm going to assign you 100 devices, right? And you can have them for the next week. And at that point, Joe bad user then launches his attack. This is the distributed denial of service today. And what that equates to, just this year, we've got a group called ERT, Emergency Response Team, and part of that team does research of the bad things happening on the dark net and attacks that are coming. We actually can warn some of our customers. We've been able to warn ahead of time. Hey, these guys have been chatting about attacking you in a week, so we should get ready. And we've been able to thwart a lot of attacks just because we know about them ahead of time. Just this year, we have found an estimated 300,000 compromised devices just in the Internet of Things, all right? And it's growing all the time. If we look at the numbers, these are the numbers. The green space is consumer devices, IP, just devices on the network, on the internet. The blue and the yellow are business IP addresses. So for a while, you could see that kind of track together. But just in the last year, the Internet of Things has just exploded. And it's projected that by the year 2020, the number of devices that are going to be on the internet, what is that, like quadrupled of 2016? So the problem's only going to get worse, primarily because the manufacturers of these things have been extremely slow in hardening their devices. So they're still listening on Telnet. They're still using default usernames and passwords, not requiring customers to change those when they get them deployed. So the problem's only going to get worse. And as an example, just in 2016, we saw a series of events where the number of devices involved in the attack grew, and as you can see, grew exponentially, 25,000 all the way to 900,000 for the failed attempt to take over Deutsche Telekom. So it's a huge problem and getting bigger, and that's why you need to be concerned about it. So why is this happening? I mean, aside from the Internet of Things, well, the Internet of Things directly correlates to this first one, more resources. There are more systems available. Back in the day, you had to have a home user with a computer that was on all the time, that was connected to the internet without a firewall, and that was silly enough to click on this happy little link and then get loaded with some kind of malware. Now, it's just all these devices that are out on the internet that are completely exposed. More targets, more and more companies are coming on all the time. Individual companies have more and more services that they are now exposing to the internet. And we're also pushing a lot more of our services into the cloud, which also broadens our internet footprint. And then finally, the environment is much more mature. And that means, and the reason for that is, how many of you have at least considered in your environments introducing more automation and more automation to simplify the tasks? That's already been done in the DDoS world, and that's what enables the bad guy to set up this huge botnet that somebody else can come in and just rent a few of them for a week or a day or a month, because of the automation tools have been applied to the DDoS arena. And so you get this, again, I've been talking about it, but this is what happens. You can go to a website and order up a ransomware attack. Through the interface, you type in your little message that will be sent to your target saying, if you don't pay me 100,000 in Bitcoin, then I will attack you on November 11th, right? It's all automated, and they click go, they swipe their credit card, and bam, the emails get sent, the devices get reserved, and on November 11th, whether you paid or not, because once the guy gets the money, if you decide to pay, which you should not pay, once the guy gets the money, he doesn't care. It doesn't affect him. It'll still fire off, and you'll still be under attack. And it's all automated. They could be sleeping. They could be in the Bahamas. Doesn't matter. So just some more frightening statistics. We are in the heart of attacks. We've got customers worldwide. When they're under attack, we work with them directly. So we see all of the attacks that are happening right now, and we create a report annually that talks about what we've seen over the past year and what we expect to see over the next year. This is some of the data from that. You can read for yourselves. I can make the slides available if you'd like. So cyber ransom is the number one reason for attacks these days. That just happened in 2016. Another thing to be aware of is that a lot of these attacks are, I'll get into it in a future slide, but SSL, as the internet goes dark, right, because everything is becoming encrypted. How many of you knew that just this year we went over the 50% threshold? More than 50% of internet traffic is now encrypted, and it's continuing to increase. Anybody? No? Yeah. So, Google did it a couple of years ago. I don't know if anyone noticed. It was really super secret. 5 years ago, you could go to Google and it was in clear text. You go http:// Google, and it stayed HTTP. Now you go to Google, and as soon as you hit the site, it goes encrypted. So, which is good, right? All your, when you're searching for kitty pictures, nobody else can snoop and see that you're searching for kitty pictures. It's great. But the problem is, from an IT perspective, now you can't see that traffic, right? Blah, blah, blah. We talked about botnets. Of course, your data is important, especially if you have records for customers, or you've got secret patents that you're trying to protect. Everybody knows that your data is valuable, and that's if they're not after money, they are after your data, so they can sell it, whether it's customer information or your IP, intelligent. Thank you, intellectual property. I'm not really a sales guy, I just played one on TV. Whoa, that did not do what it was supposed to do. All right, so again, back in the day, what we primarily saw was high volume attacks because they were easy. They were simple to execute. As we go along, because of the automation, we are seeing more complex attacks. Because they can all be orchestrated now. All the software does it. It doesn't require somebody at the keyboard, okay, now launch this attack. It's all being automated. And so what we're seeing is just a melding of the attacks. Most attacks these days contain 3 vectors, 4 vectors, oftentimes more than 7 different vectors. We've seen some as high as 15 or 18 different attack vectors in one attack. So it's not just a SYN flood. It might be a SYN flood and a reset flood and an HTTP flood and an SSL flood, ping of death, all combined all at once, making it much, much harder to detect and mitigate. But not all of them are volumetric. More than half of them are less than 10 meg. And how many here at your place of work, how many of here have an internet connection bigger than 10 meg? Yeah, pretty much everybody, right? And we were with a customer yesterday that had, we're talking along, blah, blah, blah. Oh yeah, we can protect this, we can do that. And well, how big is your internet pipe? Oh, it's 100 meg. That's it? Okay. Yeah, most people have at least a gig these days. But with that said, the attacks are small in volume. So you need to be able to, the denial of service is not just saturation of your internet pipe. It is attacking the resources in such a way that your services are no longer available, whether that be the website, filling up the state tables on your firewall, if you have ACLs on your router, on your border, your internet router, which many people do still to this day, that's a stateful process and can be overwhelmed, and it doesn't take a lot of volume. So let's talk about those now that I've just talked about them. This last year, we only saw 25% of the attacks be volumetric, where it filled up the internet pipe. Only a quarter of our customers experienced that, massive, lots of data, we can't get any traffic through our internet pipe. A quarter of them tipped the firewall over, right? So effectively the same thing, even though you're not filling up the internet pipe, if your firewall falls over, you still don't have access to the internet. Your services are still unavailable to your customers. And then, of course, where the crown jewels are, over a third of the attacks are targeting the back-end services. Yeah, 40%. And actually, one other quick note on that, the saturation of the internet pipe dropped dramatically. It used to be 30%, 33%, and now it's only 25%. So again, the attacks are getting much more sophisticated than they've been in the past. I'll just bop through this really quick. So all this is saying is that again, we think of DDoS as just one thing that we need to protect against. But what this slide is saying is that there are many, many vectors in a DDoS attack. The volumetric, which is attacking specifically your internet connection. We've got floods of various kinds, SYN floods, HTTP floods, UDP floods. We've got scans that are looking for open ports and looking for, what's the operating system or what's the service behind the port. A lot of web-based, application layer attacks. So you're not going to detect and protect yourself in just one place. So obviously the first place you could do this is in the cloud, right? If you have a cloud service stood up, routing all of your traffic through this cloud to do the scrubbing, if an attack occurs, it'll be detected, it'll be scrubbed out, and then we can send the clean traffic onto your service, whether your service is hosted in the cloud or hosted on premise. Okay. Whoa. Hyper-clicking. In order for a cloud service to work well, you need to have worldwide distributed scrubbing centers. And the reason for that, again, Internet of Things, I think, I should have had this number, I don't have it. The Mize botnet, I think, currently has, I want to say it has 10,000 is the estimate of just the Mize botnet, 10,000 devices that are under control of Mize. And there's several other botnets that are out there. There's Hajime, and there's, well, can't really call it has anyone heard of BrickerBot? No, so BrickerBot, we found BrickerBot, we published it to the world, hey, we're great. But what BrickerBot does, you can't call it a network or a botnet, because what BrickerBot does, the gentleman who came up with BreakerBot calls himself the janitor. He's cleaning up the internet. So his bot, his little scan software is looking for the same things that Mize is looking for an open telnet connection. When it finds an open telnet connection, it logs in to see if, and determines somehow, it's way smarter than I am, determines somehow whether or not it's infected. And if it is infected, then it will reinfect it with its own code and cause what's called a PDOS. P as in Papa, as in permanent denial of service. What it does is it completely erases the NVRAM, sets the settings in there to have just one thread, and basically bricks the device. In most cases, you can't restore the device. The manufacturer can't restore the device because they never planned on that happening. So now your device is a brick, hence the name BreakerBot. So you can't really call that a network because once BreakerBot infects your device is toast. But back to the botnets. These botnets are all over the planet. So you don't want to, if you get a volumetric attack where it's filling up your pipe, you don't want to protect right there at your edge. You want to be able to push that out as close to the attacker as possible, right? Nip it in the bud so it's not traversing the internet, not coming to your local cloud service. And that's what this is showing here. You have points of presence all over the planet that can do that blocking. Does that make sense? Awesome. Cool. I took a little segue there. Wanted to make sure everyone was still with me. All right, so let's talk about the entire solution. So again, old school, attack would come in, blocked by firewall, but goes volumetric, firewall falls over, that's not good. So we put in a device, some kind of DDoS mitigator, and that looks remarkably like Radware's device, but it doesn't say Radware, so I'm not selling that. There are multiple vendors out there that do this. But the key is to put it out in front of your firewall, potentially even in front of your internet router, so that you are stopping those attacks before they get to your devices to protect them, just like that. But as the attacks have gotten more sophisticated, there's a lot of attacks on the back end that at the infrastructure level, we're not looking into the application at this point. We're just looking at basic HTTP and basic SSL setup stuff. And we can move that to the same location and protect the entire infrastructure right there at the gateway to your environment. Now for the application layers, new slide. We can take it one step further with, and when I say we, again, this is very generic. If this is something specifically Radware, I'll kind of give you a signal. But by and large, anybody can do this. Of course, Radware can do it better, right? So you can get higher level into the SSL mitigation by having a device that will decrypt the SSL session. Now, again, we want to be really sensitive about what we decrypt. In this particular example, what we're going to do is, under normal peacetime conditions, we're going to let the SSL go through, right? It's all fine. We haven't detected anything mischievous yet. But say we do. Hey, there's something weird about this particular SSL connection. In some cases, you can look at several different parameters to make that decision. But once you decide that there's something mischievous about this, well, we'll take that connection, redirect it, and decrypt the first packet. And once we've done that, we can, from that device, send a challenge. We've decrypted it. Now we can see the HTTP in clear text. We're going to send an HTTP challenge. Why do we do that? Well, because our browsers on our laptops and our desktops, and even on our phones, they have intelligence built into them to make them easy for us to use. And they will respond, unbeknownst to us, to that challenge. The botnets, they're just dumb. They're just, if they get a challenge like this, they won't respond because it's not a browser. It's a script. And it doesn't know how to, I'm sure at some point, some nefarious dude will figure out, or doodad, will figure out how to respond to the challenge. But because the targets are so easy right now, they don't respond. So if a legitimate client responds, that will be authenticated. Now that goes into a temporary list that says, hey, this guy is good because he responded to our challenge. And then at that point, we'll send a redirect. Okay, try the connection again. We like you. Go ahead and try connect again, and now we'll let it through unmolested, unencrypted. So you can maintain confidentiality of the communications, but still have that higher level of protection. So now what about the application level protections? That, again, you can cause a denial of service up at the application level that a network protection device, is an infrastructure protection device, is not going to know. It doesn't have the intelligence to understand an application. So what you need here is a web application firewall. And this will actually look deep into the packet, look at how the application behaves, learn what proper behavior is, and then when it sees improper behavior, it will block it. Now you can go one step further and have that device communicate with the edge device and do the mitigation there, do the blocking at the edge, instead of having to have that traffic come all the way in and consume resources on, inside your network. Let's see what else. And then to layer on top of that, again, if the attack goes volumetric, fills up your pipe, you can have that same communication, and all of the vendors out there that have both an on-premise and a cloud offering can do this diversion. The cool part is where you can also transfer some intelligence and get better protection. But the idea is block the attack up in the cloud before it gets to your devices. Specifically here in Alaska, where you guys have limited bandwidth from the states. If you have customers that are coming from the lower 48, having this hybrid approach where you have both on-premise and cloud protection could be very helpful to you, and you could be a good neighbor, and I'll show you why. Again, attack comes in, you've got an on-premise device, it gets blocked by the device on-prem, it goes volumetric, and starts filling up your pipe. You're still blocked, but now the bandwidth from the lower 48 is getting filled up. Even if you only have a gig connection, if someone were to attack you, they can attack you with a 10 gig or 20 gig attack, which wouldn't affect you anymore because you've only got 1 gig, but could fill up this pipe. Even though it's directed at you, it's going to affect the other companies up here at the end of that connection. So by doing a diversion, this is where it helps you and helps your neighbor. You do a diversion and it gets diverted down in the lower 48, or in Asia or Europe, wherever the attack is originating from, and it helps everybody, including yourself, maintain the connectivity down to the lower 48. And I believe we started conversations with you guys about this. We'd like to continue those. Well, one of those local ISPs where the middle initial is C. Yeah. I borrowed that from him.
What could that be?
I know, right? All right. So, in summary, hybrid, good. Cloud needs to be a part of that. Obviously, the hybrid is both on-prem and cloud. You need the on-prem because, again, more than half of the attacks do not go volumetric. Actually, of our customers, only 25% of them went volumetric last year. The remaining 75% are either A, trying to get at your information, or B, distracting you from other tasks, possibly ransomware, that sort of thing. Any questions? Yes.
Could you describe in more detail the difference between somebody volumetric? How does that relate to just a regular attacker?
Okay. Well, and so actually, yeah. Let me go back to this slide because actually this is a good slide right here. So oftentimes these attacks here at the application layer are not volumetric at all. They're trying to get into the web service, right? They're trying to get into the application or even down into the operating system so they can go find the data and mine it, start pulling it out. Oftentimes the HTTP floods and the SSL floods, there's not going to be enough traffic to fill the internet pipe, assuming you have a reasonably sized pipe, but it will fill up resources on wherever you're terminating your SSL. That has a limited number of sockets, if you will, right, to terminate SSL. You fill those up, you can't serve legitimate clients anymore because you've exhausted the resources on whatever's terminating the SSL. Same with HTTP. You fill all the port 80 sockets on the server, it's not going to allow any more connections. So those are examples of non-volumetric attacks that still create a denial of service.
Okay, thank you very much.
You betcha.